Okay, so today we're going to talk about reciprocals of linear functions. And the main topic for this chapter is rational functions. Rational functions. Okay, and so rational functions are things of, I'll give you a couple examples here. Things along these lines: 1 over 2x plus 4, 1 over x squared plus 2x minus 1. Then we'll maybe do x plus 5 over 3x minus 4. And finally we'll go with maybe x over x squared plus 4x minus 1. Alright, so these are the things that we're going to be talking about this chapter. So we'll start with the reciprocal of a linear function. Notice this is in the denominator there's a linear function, and so this is actually called the reciprocal of a linear function. All right. Then for next section, we'll be talking about the reciprocal of a quadratic function. Then we'll be talking about a linear function divided by a linear function. And finally, we'll be talking about a linear function divided by a quadratic function. So these are the 4 ones that we'll discuss in total for this chapter. Okay, but for today we'll only discuss the reciprocal of the linear function. So that's kind of sort of an outline of where we're going to go. What are we going to discuss about these things? The question you might ask yourself. Well, we are going to discuss things like where are the asymptotes, where's the x-intercepts, where's the y-intercepts, what's the rate of change of these things at any particular point, and also we're also going to build the graph from the equation and build the equation from the graph. Okay, and so what we'll do is I'll just get straight into an example here. Okay, and so let's start with f of x is equal to a 1 over 2x minus 1. Now I'm going to ask a lot of things here. I'm going to ask for what is the domain. Okay. There's my alarm. Let me go get that. Sorry about that. Okay, so we're going to discuss what is the domain, what is the range, and we'll discover that the asymptotes actually have a large say in what the domain and the range is. We're going to A, B, C. We're going to talk about find the x and y intercepts, and then finally we'll discuss the sketch a graph. Okay, and that'll be enough for today. Okay, and so let's start with this. How do I find the domain of this? So remembering what the domain is, the domain is any x value that I can plug in to the function and get a reasonable answer. And so what we can do is look at the function and see, remember that the domain is along the x-axis here, okay, the x-axis. What we want to do is we want to realize what x values can I plug in here and get a reasonable answer, okay. And so for finding the domain, this is how we find the domain. You take the denominator and you set it equal to 0. Actually, you set it not equal to 0, and you say 2x minus 1. Because the reason is because, as you remember from perhaps somebody told you way long time ago, you actually can't divide by 0. And so the domain restriction would be any x value that I place in here that creates a 0 in the denominator. If I get a 0 in the denominator, then you just can't do it. You know what I mean? It's undefined, and so we want to say the domain is everywhere except for this function here. This denominator cannot equal 0. And so this might be the first time that you're using the actually doing algebra with the cannot equal sign, but it actually works quite nicely. Check this out. And so what I want to do is solve this equation for x. And so I will add 1 to both sides here. And so this is funny using a property of equality with a non-equal sign, but we're going to do it anyway. And so I get 1 is equal to, is not equal to a 2x, and then I divide by 2, and I get x is not equal to 1/2. Alright? And so what this means is, since the denominator cannot equal 0, then x cannot equal 1/2. And if I look back up in here, and if I place a 1/2 in here, I will see that, I would get a 0, and that would be tragic. And so the idea is the domain is x is a real number such that x cannot equal 1/2. So the domain is any number except for 1/2, because I can put any other number in here, because I can divide 1 by any number in the whole world except for 0. And so if I put a 1/2 in there, I would get a 0, and then it would be not so good. Okay? And so there's the domain. Now, this domain will actually tells you, since the domain is this, therefore, this little 3 dots mean therefore, the vertical is up and down. We have a vertical asymptote, there we go, vertical asymptote. That's a tough one to spell. Exists at x equals 1/2. Alright, and so we've got our domain, and we've got one vertical asymptote. Now over here on my graph, I'm going to sketch in at 1/2. This is maybe 1. This will be 2. Okay, I'm going to sketch in a vertical asymptote. A vertical asymptote looks like a dotted line. Alright, now what this means is the graph cannot exist here. Right? But it's as if the graph actually wants to exist here, but it can't. So what happens is it approaches this, and then once it hits it, it'll actually bend away from the graph. And we'll look at what it looks like in a moment here. All right, but let's actually figure out. Let's see, B. Let's figure out the range here. The range. All right. Now, the range is a bit of an interesting situation. For all of these reciprocal linear functions, for all of them, the range for all reciprocal linear functions, the range is R. Y is a real number such that y cannot equal 0. Okay? And let me explain. Oh, by the way, therefore, a horizontal asymptote exists at y equals 0. So notice for these the domain restriction produces a vertical asymptote, and that's because we can't put in this x value. The range restriction creates a horizontal asymptote, and that's because we can't get this y value out as an answer or a result. And so we end up with actually two asymptotes. I'm going to create this asymptote right over top of the x-axis. It's difficult to see there. Maybe I could make it in a different color. No, not so much. So whatever the case, I have a horizontal asymptote here and a vertical asymptote there. Now, why is this true? Let's actually look at this function here and be a little. Let's scrutinize it a little bit. If I look at f of x is equal to 1 over 2x minus 1, and I try and ask myself, okay, what possible answers can I get out of here? All right, and so notice how the numerator, there exists a value of 1. Now, what this means is there's no way that this thing will ever equal 0. And so that means the answer of this, no matter what I put in here, I can't get a 0 as the entire thing, because 1 divided by any number is not equal to 0. Because, well, if I divide it by a really tiny number, or say let's do a big number. Let's say I do 1 divided by a really giant number. Then I'm going to get a really, really small fraction. Okay? 1 over a million, for example. 1/1,000,000th. That's a giant number, but it's definitely not 0. Now, let's say I put in a really small number here. Then it's 1 divided by a very small number. And 1 divided by a very small number is actually a very big number. For example, let's say I do 1 divided by 1/10. 1 divided by 1/10 is actually 10. And then, so that's a pretty small number, 1 divided by a small number. Let's do a 1 divided by 1/100th is actually 100. 1 divided by 1/1000th is actually 1000, and so forth. And so there's actually no way for this function to equal there's no way for it to equal 0. Because even if I put a 0 in here, it's going to be 2 times 0, which is 0, and then 0 minus 1 is -1, and it's going to be 1 divided by -1, so it's going to be -1. There's no way for this thing to achieve 0. And so, why am I saying all of this? That's why the range restriction is 0. This, I can never get an answer of 0, so the range will never be 0. Remember the difference between domain and range. The domain, this is key right here, the domain is all possible numbers that I can put into the function and get out. And any number that I can put into the function is in the domain, but that number must give me a reasonable answer. Okay? So if I can put a number in and get a reasonable answer out, the number that I put in is in the domain. The range. The range is the list of all answers that I can get. And so I can't get 0 as an answer. And in this section here, I can't put 1/2 into the function. And so that is why we have these restrictions here. All right? And so let's move along real fast and try and look at the so I've got my domain, my range, and my asymptotes. Let's now try and find the x and the y intercepts real quick. Okay, I'm going to do that. It looks maybe on the next different page here. So what I'll do is I'll recopy my function. My function is 1 over 2x minus 1. We've already said that the domain is x is a real number such that x cannot equal 1/2. We've already said that the range is y is a real number such that y cannot equal 0. Okay? And we've got a graph sort of kind of going here. And the graph is a vertical asymptote at x equals 1/2 and a horizontal asymptote right there. Okay? Now you'll see how these asymptotes work in a moment. So let's now actually find the x and y intercepts. So remember, to find the x intercept, force y to be equal to 0. Or you can force f of x to be equal to 0. So I take this function and I place it down here, 1 over 2x minus 1, and I actually take it and I force y, the y value, to be equal to 0. And then to find the x-intercept, you force y to equal 0, then solve for x. When you solve for x, that's going to be the y-intercept. Or sorry, the x-intercept. Okay, so now solving for x in this function, what I'm going to do here is I'm going to take this and I'm going to place it over 1. So now what I've got is I've got a fraction equals another fraction. When I've got a fraction equals another fraction, I can cross multiply here. And so I get this times 0, or 0 times 2x minus 1 is equal to 1 times 1, 1 times 1. And now solving for this is 0 times this. Well, 0 times anything is 0. 1 times 1 is 1. And I get, ooh, look at this. I get a non-equals here. So when I'm trying to find the x-intercept here, I set y equal to 0, and then I solve for x, and what I do is I get something that's untrue. So in the end, there is no solution for this. So therefore, there is no x-intercept. Alright, and so if I go back to my graph here, that actually makes sense, because we just said a little while ago that I had an asymptote here at my x-intercept, which means the graph does not exist right there. If the graph does not exist right there, then it can't intersect the x-axis, and I can't have an x-intercept. And algebraically over here, we found that yes, that is true. Alright, so now to find the y-intercept, you force x to be 0 and solve for y, basically. Or you can also say find f of 0. So we're forcing x to be 0. So in this case, I'm going to say f of 0 is equal to 1 over 2 times 0 minus 1. And I find that it's 1 over negative 1, or a negative 1. So my y-intercept, therefore, my y-intercept is negative 1. And so I'm going to put down a y-intercept of negative 1. Alright? So if I look at my graph here, I can now make a rough sketch of this graph. I'm not going to require y'all to, and I doubt many people will require you to make a supremely exact graph of these. Basically, what you want to do is, when you're graphing these, find the asymptotes, find the intercepts, if there are any, and then perhaps just make a sketch of this graph. And so this graph is going to look like this here, all right? And it's going to actually, so I've got an asymptote here, which means my graph is actually going to come from here, and it's going to try and go up, but it will never actually touch this, and then it will actually never touch this either. So the graph actually comes down like that, and so it's basically a curve like this that's sort of trapped between two asymptotes. But then it turns out that the other side of the graph looks exactly the same. It will also do one of these things here, okay? Because these graphs have what's known as point symmetry around the intersection of their asymptotes. Point symmetry means that if I choose a point and kind of look at it as if it were the center, then the graph will have mirror images around this point here, more or less. Actually, it's called rotational symmetry as well. And so basically what I've got is, this is basically the graph of f of x. So this is 1 over 2x minus 1. This is the graph here, okay? So again, the things that you'll want to find are the intercepts and the asymptotes, the domain and the range, okay? And that's a pretty good start, okay? So that was reciprocals of a linear function. Tomorrow we'll look at reciprocals of a quadratic.